This, ladies and gentlemen, is the lesson on how to solve equations that have radicals or rational exponents in them. So this is section 7.5, page 21. When we talk about a radical equation, we don't just mean something groovy or awesome, although it could be that. What we mean is we mean an equation that has a variable, like some x or some a or something like that, inside of a radical, or that there is a variable with a rational or fraction exponent. So, for example, we're looking for something that there's an equation, means first of all there must be an equal sign. You might have the square root of x plus 2 equals 19. Notice there's the equal sign, there is a radical, and the variable is inside of the radical. That'd be one example. Or perhaps you have x minus 7 raised to the 1/3 power equals 10. There's the equal sign, there's a rational or fraction exponent, and the x is included in that. That's what a radical equation is. Remember that when we say solve, this is to find the value or values of x when the equation is equal to 0. So when the equation is equal to 0. So if you're given something that's like a y equals square root of x plus 3 minus 10, you would want to set that up to be 0 equals square root of x plus 3 minus 10. We would start to move the 10 over and out of the way. We'd start to say that 10 equaled square root of x plus 3, and we'd still keep solving for that x. So if you have the y equals, replace that with a 0. That's what we mean. If you have one where it's already set up, there is no y, it's just a number set up, like for example, example 1, there's no y. They have already set this equal to 0 and moved the 4 over, so it's set to go. But our answer is to find the values of x. So our final answer needs to have something like x equals in it. And we might have one answer, we might have two answers, we might have more, but the answer will be x equals. That's how we know we're done. So here are our steps for solving radical equations. First thing that you need to do, this is important, isolate the radical. Okay, this first one is already set up for us. The radical is by itself, but look at example 2. It is not. We have to move this guy out of the way before we can work on example 2. To get rid of the radical, we're going to square both sides. Sometimes you will need to FOIL, sometimes you do not. This first one is a not example. We will see one later where you FOIL. If you have FOILed, then you may have to set equal to 0 and factor. So these might go together in here. If you haven't FOILed, you might be able to skip all those steps and just move down to step 6, which is solving. Once you have solved, again, that means you have your x equals as your answer in here, we have to actually check our solutions. When we get solutions to these, particularly because there's square roots, they do not always come out correctly, meaning we sometimes get extras. So this is actually an important step for us in this lesson today. So let's start with this. Isolate the radical. That is already done for us here. So square both sides. So square and square. This means that the square root and the squared cancel. We end up getting just 3x plus 4. And 4 squared is 16. Do we need to FOIL this? No, there's no parentheses, there's no foiling needed here. So we actually get to skip all the way down to number 6, which is solve. So we'll move this 4 over. We get 3x equals 12. Divide both sides by 3. So we get x equals 4. And then we need to check. So back up in the original equation here, 3 times something plus 4 is supposed to equal 4. When we plug in 4, let's see what we get here. 3 times 4 would be 12, and then plus 4, and that's a square root. Does that equal 4? Square root of 16? Yes, it does. So check. This answer works. All right, example 2. This one, we have to isolate the radical. So when we do that, let's move this 2 over, first of all here. So add 2 to both sides. We end up getting the square root of 6 minus 3x equals 2. Then we have to square both sides. Square root and the squared cancel, so we get 6 minus 3x equals 4, and then just keep solving. So minus 6, negative 3x equals negative 2. Need to divide by a negative 3. So we get x equals 2/3. Remember, a negative divided by a negative is a positive. Now we need to check our answer here. So the square root of 6 minus 3, parentheses, minus 2 should equal 0. And we're plugging in 2/3. You can use your calculator to help you as well. You could just plug this whole line into your calculator and see, does it equal what the right-hand side says it should equal? We're going to check it by hand right here. So we get 6 minus 3 times 2/3 will just be 2 minus 2. So this is square root of 4 minus 2. Square root of 4 is 2, and yes, 2 minus 2 is 0. Check. So this answer is also a correct answer. Now, there's a thought for us right here that says sketch your solutions to x. Remember that we have algebraic, visual, verbal, and numerical. And so when we try to sketch solutions, what this means is that on an xy grid, this value, x is 2/3, is where you would put a dot. This is where this graph will be crossing the x-axis. So even though we don't know what this picture looks like without using perhaps our graphing calculator, we do know that it will cross the x-axis at this point. Turns out that if you go to your graphing calculator and you sketch this, you will see a graph that's kind of heading off in this direction. Okay, but this is where it crosses because, again, this is your y-axis. Let's say this is y, 5, 4, 3, 2, 1. Boom, 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 boom. This is where y is 0. When the function y is equal to 0, that's where your x crosses. Okay, more examples. Same process that we used before in terms of isolating, and then if we have to FOIL, and then solving. For this one, it is already isolated for us, meaning this phrase is already by itself. But how do we undo this 2/3? We saw that when we had a square root on both sides, or excuse me, a square root on one side, we saw that what we had to do was square both sides, and that would end up canceling the square root. But how do you cancel a 2/3? Well, believe it or not, a square root, remember as a fractional exponent, a square root is simply saying that it's x to the 1/2. So when we come in and we square both sides like that, we're actually canceling 1/2 and 2. And 1/2 and 2 are reciprocals. So the big idea for us here is that we use 3/2 on both sides. We raise both sides to the 3/2 power. So raise both sides to the reciprocal power. Raise both sides to the reciprocal power. When we do this, what is 2/3 times 3/2? Well, it cancels. It's just 1, just the same way that 1/2 and 2 canceled. So we will end up getting on this side just x minus 2. On this side, though, we still have 9 to the 3/2 because there was nothing to cancel those 3/2 with. But that's okay. We know how to deal with these. Our next step is to make sure that we convert this to a radical and then simplify if we need to. So when we convert this, this will become the square root of 9, all of that raised to the 3rd power. So x minus 2 equals, square root of 9 is 3 raised to the 3rd power, which means 3 raised to the 3rd power is 27. All of that was just taking care of getting rid of the rational exponent and then simplifying this side. After this, now we start saying, okay, solve and check answers. So when we move this 2 over, we end up getting x equals 29. We want to check it. So if we go back up to the original, we'd have 29 minus 2 raised to the 2/3 power. Does that equal question mark 9? Well, 29 minus 2 is 27. 27 to the 3/2 power is the cubed root of 27, and then we're squaring that, equals 9. Cubed root of 27 is 3. 3 squared, sure enough, is 9. Also, we could have plugged this into our calculator and see if the calculator gave us 9. So this is a correct answer. Now again, sketching our solutions, if you go to your y equals on your calculator, go to your y equals button and you plug in, it has to be set equal to 0, so we can't just do this one. We'd have to plug in x minus y equals x minus 2 raised to the 2/3 minus 9. We plug that in and we look at our graph. Let's see what we get here. So for this one here, we actually end up getting kind of a fun graph. It's a graph that kind of dips down and then dips back up again. It goes off of our calculator screen. We can't see it, but we know that where it's crossing later on off the screen where we can't see, we know that this crossing point will be x equals 29 because that was our solution. That is where the y-axis is equal to 0. So x equals 29 is where this graph will cross. All right, so what were our steps again? Raise both sides to the reciprocal power. That was step 1. Step 2 was convert this one to a radical and simplify, and then step 3 was to solve and check. Let's do these again here. Notice that this one is not isolated. So a pre-step we could even have up above here would be isolate. Let's move this 3 over. We move the 3 over, dividing both sides by 3. We get x plus 3 raised to the 3/4 power equals 27. The reciprocal will be 4/3, so raise both sides to the 4/3, cancels. And now we need to simplify this side here. This will be the cubed root, and then we will be raising this to the 4th. You might notice that I've been using the pattern where you put the 4th on the outside. The reason I've been doing that here is because it's going to be so much easier for us to take the cubed root of something first and then raise it to the 4th instead of getting a really big number and then trying to take the cubed root. So we have x plus 3 equals the cubed root of 27 is just 3. 3 raised to the 4th. X plus 3 then equals 81. And if we subtract 3 from both sides, we get x equals 78. Again, we want to check it. So 78 plus 3 to the 3/4 power, does that equal 81? You can plug this into your calculator and see if it gets you 81, or we can do what is 81 to the 3/4. So this is the 4th root of 81, and then cube that times 3. The 4th root of 81, if you check it, it is actually 3. 3 cubed. 3 cubed is going to be 27, and 27 times 3 will in fact be 81. Okay? So that's an example of how to solve a radical equation and a rational exponents equation. In these next couple examples, we're still going to deal with radicals and rational exponents, but now we introduce this concept of extraneous solutions. An extraneous solution means an answer we obtain algebraically but does not satisfy the original equation. Meaning when we go back to check, it doesn't work. Okay? An answer we obtain algebraically with our work but does not satisfy the original equation when we check. These are not true solutions. They do not work. So we will discount them. We will not leave them in our final answer. All right. Following our steps for this one, we have to isolate the radical. So let's go ahead and let's move that 5 over. When we do that, we're going to get square root of x plus 7 equals x minus 5. And when we come in to square both sides, this, ladies and gentlemen, is an example where we are going to have to FOIL. And remember our steps that we skipped before? It was FOIL, and then factor, and then solving. So we're going to have to do that for this one, because notice we have an x minus 5 squared. Square root and squared cancel, so x plus 7 equals, write it out twice please, x minus 5 times x minus 5. When we FOIL this, We get x squared minus 10x plus 25. If you don't understand how I got that, stop and ask a partner really quick, or FOIL it on your own and then simplify it. You should get the same answer. X plus 7 equals all this. We need to actually move all the pieces together here. So I need to get these guys out of the way. I can't why would I factor this if I have pieces left over? So subtract an x and subtract a 7. So we end up getting 0 equals x squared minus 11x, 25 minus 7 is 18. So I FOILed. Now I need to factor. Whether you use MAC or guess and check, I don't care. We know we need x's in the front, and in the back we're going to need same signs because it's a plus, means these are going to be matching signs, and this is a minus, so it means they're both going to be minus. 18, multiply to 18 and add to 11, this would be 9 and 2. Since this is 9 and 2, move our work up here, set each piece equal to 0. So x minus 9 equals 0, so x equals positive 9. X minus 2 equals 0, so x equals positive 2. These are both answers we think will work. When we come back to check and we say the square root of 2 plus 7 plus 5 equals 2, because then there's x's in both places here, so 2's, does this work? So square root of 9 plus 5, does that equal 2? 3 plus 5 equal 2. No, 8 does not equal 2. So this answer is extraneous. It's not a good solution. We can't use it. We want to check 9. Let's see if 9 actually works. Square root of 9 plus 7 plus 5, does that equal 9? Again, x in both places. So this is square root 16 plus 5 equals 9. Square root of 16 will be 4 plus 5. Yes, that equals 9. Check. So this one is a good solution, a true solution. All right. Same idea, but now we're going to have rational exponents. We still need to isolate, and sure enough, it is already isolated, so yay there. We need to undo this power, so we're going to 2 over 1. And when we do that to this side, we got to do it to the whole side. Notice that when we cancel these, it goes away. We're going to get 5 minus x, but on this side, we now have x plus 1 times x plus 1. Again, this is going to be another example where we need to FOIL and then later factor. So we have 5 minus x equals x squared plus 2x plus 1. Again, you might need to hit pause, try it on your own, and then double check your answer with mine for the foiling. To factor this, we need to set it equal to 0, so subtract 5's, add an x, so we get 0 equals x squared plus 3x minus 4. When we factor this, x is in the front. This is a minus back here, which means the signs must be different. There will be a plus and a minus. We need a 4. So our options are 2 and 2. But if I put in a 2 and a 2, I'm going to get 2x minus 2x. That'll cancel and give me 0 x's in the middle, so that can't work. Other options for 4, maybe 1 and 4. If I have 1 and 4, this will give me 1x minus 4x, so that's minus 3x. I need a positive 3x. That means, ladies and gentlemen, I just need to switch my signs in here. So this needs to be the positive, and this needs to be the negative. Once that's factored, let's go ahead and set pieces equal to 0. So x minus 1 equals 0 will be x equals positive 1, and x plus 4 equals 0 will be x equals negative 4. Got to check them, got to make sure they work. So 5 minus 1 raised to the 1/2 power, does that equal 1 plus 1? So this is 4 to the 1/2 power equals 2. This would be the square root of 4. Square root of 4 is 2. 2 equals 2. Check. So this answer is a good answer. For the negative 4 answer, let's try this. For the negative 4 answer, when we come in with this one, negative 4, does that equal negative 4 plus 1? Negative 4 minus 1 is negative 5, and this would be negative 3, so we end up getting the square root of negative 5 equals negative 3. Well, first of all, the square root of 5 has a negative, which means it would have an I in it anyway, and there's no I here, and there's no way that square root of 5 is 3. So no, this is an incorrect solution. Only x equals 1 will actually work for us. Okay?